Welcome to the Titus Timeout podcast. My name is Randy Zimmerman, and today I'll be discussing what's the difference between manual and remote PWM speed controllers. Generally speaking, fan-powered terminal units require a speed controller in order to make the necessary balancing adjustments to match the fan airflow delivery to scheduled air volumes. This adjustment is typically made by the balancing contractor, and it's necessary in order to compensate for external pressure and operating conditions in order to deliver design airflow from a blower. There are two types of fan motors used in terminal units. Permanent split capacitor, or PSC motors, typically use a silicon-controlled rectifier, or SCR, speed control in order to make this adjustment. SCR is the proper technical name for what most people would call a dimmer switch. These devices basically take a nice smooth AC sine wave power and chop and notch it in order to reduce the usable power supplied to the motor. As these devices are turned down further and further to slow the motor, the power becomes increasingly distorted. This can result in motors running hotter, often producing an increasing amount of low-frequency motor hum. For this reason, SCR speed controls are best suited for trimming the speed of a PSC motor and not chopping the speed. Most manufacturers limit the turn-down adjustment of an SCR speed control to no more than 50% to prevent motor failures due to heat and low-speed operation. The newer electronically commutated motors, or ECMs, are very different from PSC motors. ECMs are smart motors that can be programmed to provide pressure-independent volume control, or they can be programmed to provide constant torque. Pressure-independent control allows the motor to automatically increase or decrease its speed to compensate for changes in external pressure. Constant torque control causes the motor to behave more like a traditional fan motor and eliminates any control stability issues when operating at very low speeds. ECMs take AC power and internally rectify it to DC voltage. The integral controller for an ECM is designed to accept a pulse width modulated, or PWM, speed control signal. This type of control is far superior to a PSC motor with an SCR controller in terms of energy and efficiency. Since there's no distortion of the motor power, there's no excess heat to be dissipated, and no motor hum at reduced speeds. ECMs run cool to the touch. Most manufacturers offer a choice of speed controls for ECMs. There's usually a manual model and a so-called remote model available. The manual PWM speed control typically provides an adjustment knob or potentiometer to set the motor speed. This usually includes a digital display or LEDs to provide feedback in terms of motor RPM and/or percent duty cycle. This allows the balancer to make settings based on published calibration charts. Some fine-tuning is generally required in order to achieve the plus or minus 5% repeatability expectation in our industry. The remote PWM speed control is designed to accept a 0 to 10 volt DC signal from a VAV controller or thermostat in order to set the motor speed. This feature can be used several different ways. It can allow the unit to be balanced or rebalanced without physical access to the unit. It can also be used to change the motor speed for various operating modes. This could allow the unit to operate at summer or winter speeds, or it could be used for sequences that change the fan speed to match changing load requirements in a zone. Some people refer to this type of operation as dynamic fan sequencing. Most manufacturers can provide calibration charts that relate DC voltage to CFM for their ECMs when these motors are programmed for pressure-independent control. Some remote PWMs also include additional features. Some provide a manual speed adjustment that can be used for balancing prior to commissioning the VAV controls. It may also be possible to add a jumper to temporarily or permanently convert a remote PWM into a manual PWM. It may also be possible to add a jumper that enables the 0 to 10 volt DC speed signal to turn the motor off at voltages less than 2 volts DC. PWM speed controls are usually powered by 24 volts AC from a VAV controller, and they put out a run signal to the motor whenever powered. It's interesting to note that speed controllers generally take the place of fan relays for ECMs. Since ECMs have rather high internal capacitance, it's recommended that they be left connected to the incoming power during normal operation. This allows the motor to be fully charged and ready to start with reduced inrush when commanded on by the speed control. So be aware of the different types of motors available in terminal units and the different types of speed controls they use. Thank you for tuning into our podcast. We hope that this information is helpful. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.